Hello. This lecture introduces 3D printing processes for metals. Well, uh, as a result of this lecture, you will know what are the different 3D printing approaches in case of metals and what are the specific aspects of these processes. In fact, there are several metal printing processes available on the market. However, there are limitations, so many limitations for printing these metals. On the other hand, we have also new opportunities, new and very powerful features open up when we're using printing of metals. Different technologies can build parts with different properties. However, users have to know these processes or the specifics of these processes to select the most suitable technology. But this can be complicated in case of new technologies. That's why we want to address the issues here during this lecture. There are different approaches how to make parts or how to 3D print parts using metal materials. There are four main types of processes. Let's start by introducing powder bed fusion technology. So in powder bed fusion technologies, we are using powder as a raw material, and like in some plastic printing technologies like selective laser sintering, we are putting or spreading layer of powder on top of the building platform. Then we are melting the cross-section of the part with laser or electron beam, and then the powder particles are fused this way that it will solidify, and layer by layer the part is printed. Here there are some specifics when compared with plastic printing. Here we need, for example, support structures to hold the parts in contact with the base plate, because the temperatures are very high, and thermal expansion and these effects might change the part position. That's why we need supports. So the second approach is to use directed energy deposition method. In this technology, we're using heat source. It can be laser, electron beam, or gas tungsten arc, and we're creating melt pool, and then we add material to the melt pool, and that's how we are building the surfaces or the layers. The filler material can be in form of powder or even wire. So there are differences when we're using powder or wire. Productivity is one issue, for example. So this technology can be combined with multi-axis milling technology, for example, to improve the surface quality. And here we can also mix the powder this way that the properties of the part can be different in different areas. This opens up very interesting opportunities. The third option is to use material jetting. This is similar to the technology used in case of plastics, where we use powder material and we are printing glue where the part has to be. So the glue is binding particles together, and they are glued to the previous layer, and layer by layer we can build 3D model this way. However, only glue is holding these particles together, so it's not very strong. To increase the strength, we can post-process in oven. And sometimes we can also use infiltration with the hot liquid metal to fill all the pores. And this way we can increase the strength and also introduce new properties. For example, if we are infiltrating the base material, which can be steel, for example, if we are infiltrating this with liquid copper, then we are introducing higher thermal conductivity, so new properties again. And the last category of metal printing technologies is sheet lamination. So in this technology we are using sheet metal. The raw material is in sheet form, so we are cutting out cross sections of parts and we are stacking them on top of each other. So this way we can create strong parts. Yes, of course we can. We have to somehow attach these cross sections on top of each other. We can use gluing, we can use welding or some other technologies. So this way we can create again different parts when compared with other technologies. So cutting out can be made with lasers or water jets and so on. And here we can use also thicker layers if needed. And if the stair-stepping effect on edges is the problematic, then we can add post-processing to these edges or these surfaces, and we can use milling. So coming to this post-processing, in metals it is in many cases post-processing is needed, and in post-processing what we're doing here, we are removing the parts from the base layer. So because of the high temperatures during the process, in most cases we have to use supports to attach the parts to the base layer or base plate. So when we are using supports, it means that we have to remove them. But as metals are quite strong, removing the supports can be challenging. So we have to use cutting tools to do it. And also the supports leave the marks on the surface. So we have to post-process also these surfaces, which in case of more complicated parts can be quite challenging task. But typically CNC milling technology is used for that. And there are some limitations when we're talking about surface quality. And, the surface quality could be better, and if we want to create really good surface, then we have to post-process it using milling and polishing sometimes. And if we have to assemble parts together with some other parts, then perhaps we should then again use cutting technology to make these interfaces more accurate. So post-processing is very important in case of metal printing. Now on this slide you can see some examples of printed metal products. Now depending on the design, we can print some moving parts without assembling them, but it's tricky. And very positive thing in case of metals is that there are new possibilities that this technology opens. We can create so many different, more complex designs, offering new opportunities. For example, here on this picture we can see optimized or structures with topology optimization, or structures that use minimum material or optimum material. Or for example, here we can see one heat exchanger which works more effectively than traditional ones. So there are different opportunities offered by these technologies. So to sum up, I would mention that 3D printing of metals is used in many industries already today. Technology is complex and systems are, right now they are quite expensive because high temperatures are involved, and it can be sometimes problematic. Metal or material grades that are available for 3D printing, grades are limited to these traditional ones, but it's widening all the time, the assortment or the selection of these materials. However, the most important thing here is that this technology opens many new possibilities for producers and designers. So this field is quite new, and many companies are looking for solutions here, how to solve old issues using new technology, and it's quite promising. Thank you for your attention.